Okay, so I thought I'd do an update. I'm printing the canopy at the moment to wind my coil on, which is going to be about another 2 hours or something. It's a bit of a drag. I came across another interesting thing. So what I did was, as I explained previously in another video, when I designed my segments, I designed them to fit shims which I'd laser cut, and these steel shims are exactly the same size as some magnets which I've been using. So what I did in the rotor assembly was I swapped out 3 of the segments. So I took out the segment, I don't know if you can see this, took out that segment there in the rotor, that is, and I took out that segment there, which is my steel shim, and I replaced it with magnets. So I've got a magnet in there and a magnet in there, but the rest of them are all just steel coupling shims. And the reason for that is that the idea I had was that the magnetism from the magnetic stator, which is in the middle, which is the stator in the middle, which is not actually moving, the idea was that as this segment passes the magnets inside, it will help to pull that flux out because it's in series effectively. So it will help to focus the flux along the steel shims out to the outside area where I need it, because the magnet is basically in series with this magnet which is on the stator. Anyway, having done that, if you remember previously, we were getting a peak of around 20 milliamps at the current input current. We were getting a peak of about 20 milliamps. And what do we get now? It's been on current all the time, by the way. Yeah, double. So we're getting double, and is it dragging it? Is it slowing it down? Well, no, it isn't. Go to frequency, it says 61. Actually, I think it says 61 Hertz, but I'm pretty sure it's higher than that because my oscilloscope says it's around. Anyway, I've forgotten now. I've forgotten now, but it said it was around 200 Hertz, which I don't know. Maybe my meter just can't read the frequency properly. I don't know, but it says 61 Hertz on here, 62 Hertz. So, my elastic band's acting up at the moment. Just a minute. The reason for that, I'm using elastic bands still, and the problem with elastic bands is they get sticky, and when they get sticky they start to dance around like that, and that creates more drag and the thing slows down. So the elastic band is creating more drag than the load. Interesting. So what I've been doing is I've got a it's come off now, look. Elastic band's come off. Where's my paintbrush? Shit. Go on. Try and get the damn thing on. I was going to get some come on. Got you. Right, what I need to do is get some I've slowed it right down now. I need to get some talcum powder on it, which is basically French chalk, because the rubber. Just do this. Sort that out. I need to put the proper belt on it actually, but I found out this usually the elastic band works pretty well. There's not much in here. I'm trying to get it out. Oh, come on. Where are you? Trying to get some on the brush. It's right at the bottom. I don't want to spill it. Here we go. got some all on my finger. That's better. Push the belt back a bit. Yeah, it's running a bit better now. It's talcum powder is good to stop the rubber from getting sticky. That's speeding up now. So I can't see in the bottom of here. Oh, it's right at the bottom down there. Can't get it. Let me just tip this out a bit. Okay, I've got a bit there now. Need to get some more of that. Yeah, I remember I did the talcum powder thing with the electric fan in a video ages ago. How to lubricate. Well, talcum powder does both. It lubricates and it gets rid of that stickiness that you get when it's rubbing on and hopefully that'll stay. Right, so I've got the talcum powder on my rubber band just to keep it from sticking. I don't know how long it'll last. It won't last long. This rubber band's probably going to snap. So, and we're at we've actually picked up some speed now. We're at 65 hertz. Let's go to current. And we're at 42. We're still climbing. Milliamps. 42.2 milliamps. So that's double what I was getting before, which is great, and it's not actually causing any drag. So having the extra magnet, putting the magnets in the rotor themselves at that particular pitch angle is reducing drag. I've got to turn my meter off when I'm not looking at it because it runs my battery down. I haven't put another one in yet, no. Oh, this belt's doing it again, it's dancing around again. I can't seem to get right temperature today. I keep taking my cardio up and I get cold, and then the next minute I'm hot. Oh, hormones. Right, so yeah, this I need to adjust this motor pitch as well to keep the belt from running off the edge. I know what I can do. Oh, I know what I can do. Let me just I'll pull this motor out of it. Might come off the pulley though. Actually, no, I don't think that's going to work. It'll just come off there if I pull the pulley further out. It's riding off the edge for some. Oh, I know what I need to do. I need to change the pitch of the rotor assembly. That's what I need to do. I can do that by pushing this one back a bit. That's better. Which is a good thing with the stand, you see. With it being on this stand, I can adjust the azimuth of the rotor assembly so that it doesn't cause this band to start riding off the pulley. Yeah, that's better. I might move it back a bit. Let's see, can I go back a bit more without it catching? Yeah, just a bit. That's better. It's running a bit better now. So, take my phone out of here a minute. Get it out of here. Don't want to press any buttons. The buttons are on top. I try to keep the buttons on top so I don't accidentally keep pressing them actually. Right, so current. Let's go back to current. Turn it on. We're still on current. I haven't moved it. I've just turned the meter back on. See what we're at the moment. We're at 42 milliamps at the moment. Voltage is a bit better as well. Voltage is 0.36 volts. Still not half a volt, but hey, don't panic. I'm printing my canopy to wind a bigger coil on. So when I get a bigger coil wound, with thinner wire and a lot more turns, we're going to see some serious volts, hopefully. So that's volts, 0.3670. Still picking up speed. Let's go back to current. It just seems to fluctuate a little bit, goes up and down. Something to do with that rubber band. But actually, yeah, I don't know about putting the magnets in the rotor might actually be detrimental to it, but that's why I'm keeping the magnets in the stator mainly. Let's just interrupt, let's take the lead out and plug it back in again. I'll take the lead out a minute, see what happens. Come out. Right, I've unplugged the lead. Without moving the setting. Because when you first set it to the setting, it has to calibrate itself, so I want to keep it on that. Let's plug it back in again, see if there's a change. Still has to recalibrate it, so it's not too bad. It is losing a tiny amount. That's because the magnets in the rotor aren't being shut off. Like in the stator, as I said, as the laminations pass the stator magnets, the flux is basically being shut off at a certain point. Well, having the magnets in the rotor, I wanted to have them there simply to pull that flux out onto the rotor assembly. So I'm going to leave them in the rotor assembly, but I'm not going to add any more because otherwise it'll just create more drag. But at least the idea seems to have helped a little bit by basically sucking that flux from the stator out to where I want it on the edge of the rotor assembly, which is helping a lot. So I'm waiting for that to print, and it's going to be, oh god, quite a while. Still get through it. Once it finishes printing the bottom section, it'll get through that print a lot quicker once it does that. I had some issues when I was printing the coil winding bits. I had to put some ABS plastic on the bed because some of the things didn't stick properly, but I'll be alright. I'll clean it up when it's printed. Yeah, my belt, the rubber band is running a bit better now. I don't know what speed. Oh, it's catching again. It's maybe dancing on that one, and sometimes it just rides off the pulley. Yeah, well that belt, but it's rubber band. It's crap. Wait. It seems to have less friction than my black belt does. My black rubber band belt, drive belt, seems to do anyway. I think it's because the black one's a bit tighter. Puts more friction on the bearing. I'm not sure about the RPM, but I think we'll be about 1,300 RPM or something like at the moment. I'll try and find out. But we're actually using a bit less current than before. Well, we're actually look a bit over what we need to be. Let me just connect my RPM meter a minute. See if I can just get a reading. I don't know where the sensor is. Where the heck's the sensor? Oh, here it is. Right. Oh, I'm tangled up. Just want to get a reading to see what it is. It's 1,000. Oops, moved it accidentally. 1,251. Still picking up speed. I need to check this actually. I need to check this when I turn the load off. I'm holding the damn thing. I need to get this. I need to make that mounting bracket, but I've been so busy in SketchUp with all the other stuff, I just didn't get around to it yet. Still climbing. We're still under load, by the way. Current wise, we're at 42.2 milliamps right now. Oh, hang on, my hands drifted away from the sensors, drifted away. Yeah, so we're doing good. Right. So, yeah, I'll have to get this thing mounted because I was using that helping hands thing to hold it in place before, and there's not a lot of room on the table, as you can see, and it's a bit cramped. And when I've got that helping hands, oh, not was it helping hands, it was that magnifying glass with it stuck on there, and it's just, I ain't got room. So I need to, I'm gonna model a little thing to sit on this top bracket and hang the sensor over the edge to just basically mount it quickly and dismount it quickly, so I don't have to fart about with it. Something I can quickly do. I'll model that in SketchUp probably as soon as I've finished up getting that printed, and I've got the art to sort out on the screening material. I haven't done that yet, so I've got to, you know, as I said, it was causing too much drag at the moment, so I need to adjust that. I've got to adjust the bit in the middle so that it's not cogging too badly. I've got a few more important things to do first before I do that sensor, really. So anyway, okay, so just a little update on everything at the moment. Oh, what current are we at now? 41.8 milliamps. So I better turn my meter off before I forget, because that's it for now. Be back later.